Hello, everyone. My name is Sasha Zelenovic, and I'm the Developer Marketing and Advocacy Manager here at Red Hat. Love vLLM, just like my colleague Michael over here. He's a vLLM committer, so if you're new to these office hours, welcome. If you're not new, welcome back. Also, if you're not new, you can probably realize that the first slide looks just a little bit different. We don't have a special topic today, so it's a pretty clean slide. So this is our 44th office hour session. Kind of hard to believe that we've been here so many times together. But we're gonna go today back to our original roots. When we started these office hours, sometimes last year, our goal was to just provide a safe space, an open discussion place for the community to come, interact, learn about what's new in vLLM, ask questions, have an open discussion. And then ultimately we started adding special topics. And we haven't had like one without a special topics probably for a year at this point. So I'm kind of excited. I know it's a miss to an extent not to have a special topic, but I'm also a little bit excited to just share the new release and what's going on, and hopefully we'll hear from you. So as Michael is talking through the new release, please, think of questions, think of feedback that you have, and it doesn't really have to be about specific to this, or the 16 release. You can ask anything you want. I think we probably, between Michael, myself, and the community here, we probably have a lot of the answers here for you. So if you want to go to the next slide. So let's do something that we used to do last year all the time. So if you can pull up your chat and just tell us where you're dialing in from, we would love to know where some of you are. We used to do this all the time. So I'm going to read some of the names. So just pull up your chat and tell us where you're dialing in from. Seattle, sweet. Hi, Thomas from Seattle. Nigeria, love it. Love it. That's probably as far east as we are today. Boston, New York. You guys from New York. I'm in Boston myself. Sweet. Toronto. We have some coverage. Anybody from near Paris? Awesome. Love seeing Europe here. More Boston. Sao Paulo. Hey, Max. Always good to have you. Quick update for you, Max. We are talking about bringing a vLLM meetup to Brazil, to Sao Paulo. So I'll definitely let you know once I have a little bit more details on that. So New York City, San Jose. I was just going to say anybody from California. There's always California here. Good to see you guys. Boulder, Colorado. Yeah, so welcome, everyone. Super nice to have you. Michael, if you want to go to the next slide. And while you're doing that, I do want to mention something. If you are seeing this, you're probably not here from China right now because you're probably sleeping, but if you're seeing this recording somewhere and you're like, man, I wish this was actually done in my time zone, actually it is being done in your time zone. So we do translate these office hours into Mandarin. So 2 weeks later, we'll run the same exact topic. So we're 2 weeks behind, but we do have a team in China who is running this through, I believe it's through WeChat and maybe some other platform. So if you're curious, or you have colleagues in China that want to do this in their appropriate time zone in Mandarin, just let me know and I'll get you some of those links. So yeah, I said there is no special topic today, but we do have an awesome lineup coming up. So in 2 weeks, Michael and I are going to be in Vienna for a vLLM meetup. We'll be talking, intro to vLLM, project update. We'll be talking about all sorts of compression techniques, vLLM Omni, bringing AI to Kubernetes through LLMD, and we'll be streaming that meetup at a different time. It should be on your calendar already. If not, I'll definitely send you an invite in the next couple of days. So we'll be streaming that meetup through YouTube Live. So it'd be cool if you guys can join and engage with us. That would be amazing. 2 weeks later, AMD will join us to talk about the latest trends in AI agent applications with vLLM. And then 2 weeks after that, we're already in April 9th, we're going to have one of the core committers to the vLLM Omni project join us and talk to us about vLLM Omni and how you can, serve multimodal models for easier, faster, and cheaper. And then lastly, and this is still to be confirmed, but I'm pretty excited. I know the community always asks me for at meetups and events, even during these office hours, like, how about vLLM on CPUs? Well, we'll be bringing Intel on. We'll be talking about how to run vLLM on their CPUs with decent performance. So we'll be talking about what the performance is. We'll show a demo. So I'm pretty excited about that session. We're still confirming the exact date for that one. Seems like it's April 23rd. But don't mark your calendars yet. We'll definitely let you know. This meeting is being recorded. You can see all of the recordings and the slides on YouTube. All of the links are there. And Michael, if you can go. Oh, actually, you in the project update here, Michael, and then pass it back to me for one more thing.
Yeah, for sure.
Oh, Michael, you're having audio issues again. You sound quantized. That's not very good. He'll be back. This happens to him every now and then. I think we have to get my new machine. Hey. No, I hear you. I see you speaking, but I can't hear you at all now.
You're muted.
Yeah, maybe. Yeah. There you are. Go ahead.
Yeah, I'm definitely due for an upgrade cycle. I think I've had this machine for almost 6 years now. 5 years at least. I love my M1 Mac. Yeah, so hey everyone, good to see you again. It's been a hectic 2 weeks getting this release out, but we finally have vLLM 0.16 to talk about. We also have a lot more model releases and some interesting blogs to dive into. So we'll share a few of those, especially I think the GB300 results and numbers will be interesting for a lot of performance and hardware junkies. Yeah, so we'll go ahead and give Sasha his plug.
Yeah, and I've just a couple of more and I'll pass it back to Michael. So we are doing a lot of meetups. I actually shared with Michael yesterday through Slack that last year we did our first meetup in Boston. That was in March. And so less than a year ago. And then our goal there was to do one meetup every 2 months. And here we are less than a year later, almost a year later. And we're doing about 5 every single month, roughly. So there's a lot happening. We're really all over the community. Most of these meetups are packed, so we really appreciate the community coming and supporting us. We just did one in Munich, so that one is done already. We did that one earlier this week. We had over 200 people join, and it was pretty awesome to hear from Red Hat and NVIDIA. Mistral was there. So we try to switch up the agenda for most of these, for sure. Michael is definitely running his typical intro to vLLM and project update, but there's all sorts of different exciting topics. So if you're in any of these cities, or if you want to travel to these cities, or if you have colleagues in these cities, please send them this list. If the meetup said it's packed, it's waitlisted. If you're at these office hours, I can probably promise you we can probably do something about that. Just Slack me, and we'll definitely get you in. And this is, again, just for Q1. There's probably going to be equally as many more for Q2. We haven't even started planning Q2 yet, but there, we're thinking about Paris, we're thinking about London, Boston. Actually, Boston is already here, even some more in New York City and West Coast as well. So more to come on meetups. And then just one more slide, Michael, from me. So my team has created actually a monthly newsletter that we would love for you to check out. So it's a completely open source newsletter, no product pitches, nothing we're trying to sell you by any means. It's fully open source. A lot of vLLM, but also other projects like LlamaStack, like MCP, like LLMD, even more. So definitely sign up for it. It should be in your inboxes coming on a monthly basis. So we'll share hands-on demos, deep dives, technical deep dives, and just a lot of different open source ways, pretty much how-to content on how to actually do cool things with AI using open source technologies. So QR code is right here. We would love for you to sign up and expect your first edition to come sometimes in April. And if you have any feedback about this newsletter, just respond to that email, please, and let us know how we can get better. All right. With that said, thanks, everyone. Super happy to have you here. Michael, back to you.
Yep, great one, Sasha. So let's get into it. If you're not familiar with vLLM already, it's definitely worth an explanation. It is the high throughput, memory efficient, open source inference engine standard for serving large language models on your own hardware. It's the most popular one for good reason. It has a very vibrant, active community. Over 2,000 people have landed code in vLLM. Just the project itself, not counting all the other sub projects in the ecosystem. And we have thousands of people in our developer Slack, so you're definitely welcome to join slack.vlm.ai to let us know if you're using it or have suggestions. It's used in production, around the world by dozens of major companies. Many of those have contributed back to vLLM upstream themselves. It's Apache 2.0 licensed, Python-based library. It's just a simple pip install away or a Docker run away. And it gets its popularity from supporting a wide variety of models, basically any large language model that works with Hugging Face transformers, works in vLLM as well, and has performant implementations across not just text inference, but also multimodal inference, useful for reasoning models, for encoder models, obviously decoder models, and with new projects like vLLM Omni working into omni-modality as well for multimodal outputs or diffusion models. Now, of course, it gets good performance on NVIDIA GPUs, but part of the power of the software abstraction that vLLM provides to hardware vendors is making it easy for their hardware to support all of these hundreds of different model architectures. So we have hardware backends from AMD, from Intel, from Google, from MetaX, from Apple, AWS, and so on. You can see the long list there, and there's even more out there from the community. And vLLM can efficiently run models on these variety of accelerators, not just on the single hardware accelerator case, but also the multiple accelerator case running models on multiple GPUs or processors inside of one node with like tensor parallelism, pipeline parallelism, and then extending to even multi-node cluster scale inference for state-of-the-art models like DeepSeek or Kimi K2, running large-scale data and expert parallelism across clusters of GPUs, and even allowing for disaggregating prefill and decode operations into different engines for scaling and building your stable inference services on top of this core project. So hopefully that was a good basic understanding of why we're here and why we're interested in vLLM and why so many people are. So now I'm going to get into some updates since the past 2 weeks. We've had a nice flurry of great model releases, particularly fighting at the state-of-the-art and mid-level state-of-the-art for coding and agentic models. Minimax released M2.5, which is a very, very capable coding model and agentic model with efficient attention for working really well at long context without while maintaining decode performance to be very high. Very happy to support that on day 0 and have it be on par with some of the closed source frontier models. I'll also make sure to check out, I'll put in recipes, like recipes linked in vLLM for how we recommend running these models with vLLM and any tips or tricks that you might want to know about. Next, we had a collaboration with the SkyRL team, which is a reinforcement learning library made by the folks at Anyscale. This has been a great project that's been developing along nicely and uses vLLM as the core inference engine in its reinforcement learning loop. They've launched their Tinker API, which Tinker is a really user-friendly reinforcement learning on LoRa API that was introduced by Thinking Machines in their API for it. And one of the great things that SkyRL and other projects in the community have done have taken the UX of that API and put it into open source projects like this, so you can host your own Tinker-like service and start to experiment with reinforcement learning really efficiency at scale, training many different types of reinforcement learned models or agents specialized on different tasks. So yeah, we're really excited to see this progress from the community there, and really the vLLM working on local GPUs here and also data center GPUs, scaling and with the very important use case of reinforcement learning as that develops and grows in the research and enterprise community. Next, we had a vLLM blog posted pretty recently. Here we kind of detailed how vLLM works on NVIDIA Blackwell Ultra SM103. So that's B300 and GB300 GPUs. And we showed some results running DeepSeek R1 and DeepSeek v3.2 using new sparse MLA. And showing basically how it scales across FP8 inference and of course FP4 inference, comparing the previous generation of GPUs, NVIDIA Hopper H200 with B300, GB300, and sort of seeing the huge amount of improvements you can have there, especially once you disaggregate inference and start to scale out your deployments of large frontier models like DeepSeek to multi-node. And really, I think the numbers speak for themselves. The difference is 8x or 10x larger than the previous generation. So it's really great to see vLLM able to take advantage of this new latest hardware of the day and make sure it's well utilized. So yeah, lots of tips and tricks in there and insights into all the work we've done to get to this point. And we have a lot more to do, especially with DeepSeek v3.2. Where we're doing an active model bash work stream for that. A lot of work to do to tune the sparse MLA, especially. So if you're interested in helping out, we have a lot of pointers and issues to let you know what we're working on. And hopefully we will summarize them in the coming weeks as we get performance to even closer to where we'd like it to be. Next, we had a really big series of model releases. Qwen released their latest state-of-the-art model, Qwen 3.5 398B. And then in the following week, this week, at the beginning of the week, launched their sort of medium series, the 122B, 35B, and 27B dense model. So really, covering across the stack of the high end and the medium to lower end models. And it's just a really high quality model, benchmarks really well across the board, and has a really efficient hybrid attention architecture, fusing gated delta networks and gated attention, along with a very, very sparse mixture of expert architecture. So yeah, Sasha, you have a question?
I know that our team released FP8 quantized versions of these. That's correct, right?
Yeah. There's quite a few now. We have FP8 checkpoints, or checkpoints, all on Hugging Face. So and there's actually some made in the community too on top of LM compressor. So it's some great ways to run the model on different scales of hardware. I think it was pretty hard for people to run the 400 billion parameter model when it released, but yeah, a lot of work done there. Yeah, and more optimizations to come, honestly. Sort of the gated delta networks haven't been tuned far enough in vLLM to at least my taste. And especially since this is a natively multimodal model, it comes with vision language understanding, image or video input supported. There's also a lot of optimization work there that it's good, but we want to tune it some more. Yeah, and last up in terms of models, just the other day, Liquid AI released their largest model, which is still a pretty small model, only 24 billion parameter MOE. But in their usual fashion, it's a very, very, very efficient model for its size, and maintains really great performance, fitting in pretty small local GPUs. So yeah, we're happy that to support that team, and yeah, hopefully make it easier for people to run these models on local or very high interactivity deployments. So without further ado, I'll get into what's new in vLLM 0.16. It was delayed quite a bit. Not really because of bugs and issues like that, more because we ran into issues upgrading PyTorch 2.10 because there was essentially a conflict with the default version of that PyTorch 2.10 was built for against CUDA on PyPy, and we didn't want to break people's simple pip install vLLM workflow. Essentially, vLLM builds for CUDA 12.9 by default, and Torch builds with at least that version of Torch builds 12.8 by default. And there was sort of a conflict of library dependencies that would cause issues for people on either of those versions. So we decided to revert back to Torch 2.9.1 to keep the behavior the same. And we've worked with the Torch team throughout this release process to map out what's going to happen for the next Torch release 2.11 to resolve this. And thanks to the new, much more often PyTorch releases, I think instead of releasing on a quarterly cadence, they're going to release on a bi-monthly or possibly even a sooner cadence. So it shouldn't be too long to wait for a PyTorch upgrade. And like I said, we're working with them there to hopefully avoid these issues in the future. But within this release, we still have a ton of model support landing in stable release like GLM5 and several of the OCR models that I covered in the last office hours. We've also been steadily working on Eagle 3 support for more types of models, including multimodal models. We've been doing a lot of work on LoRa expansion to more components of the models, expanding them to the vision components of vision language models, extending them to the speculators. So running on MTP or even Eagle modules potentially. And we've also been tuning the performance of LoRa with MOE models heavily, which a lot of those got into this release. And you should actually look for a blog soon from the Amazon team that's been driving that forward. Yeah, we're working on publishing that now. Yeah, and then in terms of the engine core, there's been a lot of work on improving the performance of async scheduling, both with pipeline parallelism. We had a huge throughput improvement there because previously pipeline parallelism wouldn't be compatible with async scheduling. And by introducing that compatibility and also tuning it a bit, offers a really large throughput improvement there. We also optimized speculative decoding with async scheduling more. We have even more enhancements on the way there, working on zero bubble spec decoding. And yeah, in terms of both features and performance with speculative decoding itself, we've landed this large unified parallel drafting work where we want to sort of unify the idea of drafting multiple tokens at once from your draft model or your Eagle speculator, rather than needing to run through a single module multiple times to predict each draft token. And this was needed to support the method from AMD and the P-Eagle method from the AWS research team, which we were really happy to be a part of their paper launch, using vLLM to build that parallel Eagle result. And so, yeah, this PR was a key enablement part of that. And, we're working closely with those research teams to integrate those parallel speculative decoding training methods into the speculators library so people can start to train those more efficient draft token generation methods themselves. And then, of course, we're working to tune the performance even further in vLLM. Yeah, which hopefully you can stay tuned for when we have some cool numbers to show there. As always, we've been chugging along with RLHF. We've been working on some optimizations for the weight syncing API, now introducing a nickel-based one. And also working on refactors for making online quantization more of a first-class citizen with the constant weight syncing that we need for RLHF. We've also been moving work ahead quite well on integrating Helion into vLLM, adding various key architectures or key points of the architecture that we need to integrate it, like managing the various auto-tune configs and registering different kernel backends in our existing custom ops. So yeah, great work there, and hopefully we'll have some performance wins to show off there in the coming weeks. Also, just other general refactors like pluggable layer and initial work on vLLM IR, which it isn't quite on here yet, but we're working on integrating that and refactoring the code base to hopefully generalize custom ops a bit more across operations. And yeah, sort of just general performance improvements in the core as we find bugs and squash them. In terms of hardware, as always, we've been chugging a lot for NVIDIA, AMD, Intel, and ARM CPUs. On NVIDIA, we've been working a lot on Blackwell and Blackwell Ultra and Blackwell RTX performance and feature parity. A key integration we made is now using a unquantized MOE implementation from Tensor TLM. Improving the performance over the Triton kernel we'd be using otherwise, and really making a large impact for low latency use cases. And also, as I kind of laid out, optimizations for gated delta networks, like for models like Qwen 3.5 and Chameleon, improving improving MLA performance, improving a lot of low batch, DeepSeek performance to really improve those, low batch size, high interactivity workloads on DeepSeek models. And just tuning away on those things that I already mentioned. In terms of AMD support, they've also been tuning away, particularly on Qwen 3 Next, which is obviously important for Qwen 3.5. Those architectures are very similar, and working towards closing the gap there, and making improvements to GPT OSS as well. In terms of the Intel hardware support, we did officially deprecate the Intel PyTorch extension and switch to the vLLM XPU kernel's external library. So that should keep less of those sort of Intel specific things in upstream vLLM, and sort of have a cleaner separation there, and also hopefully allow the lag that they face with PyTorch updates to be decreased. ARM CPU has had a good amount of work, especially tuning v0.16 performance. And in terms of Torch compile, we've been working heavily on improving the cold start and warm start compilation times, cleaning up some of the tech debt that is built up there, and overall managing the Torch compile cache with more stability over long periods of time, as we sort of noticed that the size of the cache can get quite large when you use vLLM across a lot of different models and configurations on a single system for a long time. Yeah, and that's kind of all for here. One note we did, as part of our deprecation RFC that we laid out for quantization backends a few weeks ago, we have removed the BitBloss library and the Marlin 2.4 libraries, as these get very little usage, and there aren't many checkpoints out there that users seem to be using. Next, we had some really big introductions into the API and front end, most notably the real-time API, which was a key part of the Mistral Voxtral real-time model release that we went over in our previous office hours. So now landing stably in this release, and now introducing WebSockets into the real-time streaming API, which is cool, especially since that's how OpenAI seems for their real-time API. So we're matching up there quite well. And a lot of improvements, across the board for the responses API and tool calling quality and bug fixes. We did some specific optimizations with structured outputs when used while the model is reasoning. Optimizations to do across the board in tool calling and reasoning parsers. So if there's interest in joining that effort, we have a Feat tool calling channel where we're looking to start a regular meeting there to coordinate work on that. And yeah, a variety of UX improvements, trying to clean up the logs a bit, provide better summaries to users. And in terms of large-scale serving, we're still working on our major 3 categories there: disaggregated serving, improving the reliability and different implementations we can use there. Developing more of a stronger connection with the Mooncake library, and like I said, fixing bugs or hangs with the Nixle connector. We've also been improving EPLB performance quite consistently, and have recently landed capturing where the experts are and how tokens are being routed to which experts with router replay, which is important for alignment during RL with the training runner, so that we understand how experts are moving during inference, and that those happen the exact same way during training. And improving metrics for better visibility as we run vLLM more often at a large scale. So that's all I have for the release update. Tried to be as verbose as I could, but there's still plenty of things missing. So check out the release notes if you're curious about anything else. And now's a great time to ask for questions if you want to hear anything covered in more detail. So let me check if there's been some comments. Yeah, we'll appreciate pointers towards sparse optimization. Great question. Yeah, let me pull up the tracking issue for DeepSeek v3.2.
Yeah, while Michael is doing that, use the chat or just speak up. Come say hi. We'd love to see your face, of course.
Yeah, so this is like the tracking issue. I'll link it in the chat. Yeah, we have a lot of work to do here. Already a good amount happening. Particularly, we've been already landed some top K optimizations. Particularly for shorter context decodes. And we already have in progress some long context improvements for decodes. And I don't think we have it here yet, but kind of where Roberto actually on our team is focusing a lot on the pre-fill performance. And we do actually have a top K optimization here to walk through. But you can see we're starting to fill out a bit of these issues, but we still have plenty that don't have PRs. So if you're interested on taking them up, there's also some discussion in the tracking issue themselves. If you're interested in, picking up some of these things, I think especially some of the context parallelism, this decode context parallel, adding that support, see if it works, first of all, and of course tuning the performance and making it work well would be especially appreciated. But there's lots of little kernels to dig into here. Where we can improve in performance, and actually just looking at some of the PRs that have already been done, you can see some great analysis into how to do this type of work, which Roberto has been doing a great job on in his micro benchmark studies and end-to-end benchmarks. So yeah, that's that little bit. Nice question. Any other questions from folks? Feel free to come off mute as well if you don't want to type.
Hi, Michael. I have a question. What's the current state of the Transformers 5 support?
Yeah, that's a good question. I actually haven't been following too closely on that. I think it's close. I've definitely been kind of annoyed by it myself, and definitely want it in ASAP. Ultimately, Harry from the Hugging Face team is best in the know about that. But I do know he has a sort of long-standing PR that's crunching through that. I think this is the PR 30566. You can see from December. There's a lot of changes that basically we've been pulling it out of this PR and landing them piece by piece. And you can see, obviously, there's been a lot of changes and things done along the way. We are actively working on it, but ultimately, we're really trying to keep the stability down. And unfortunately, there are a lot of issues. In the V5 release, it breaks some, old model implementations, particularly a lot of models that were relying on out-of-tree transformers code. So, working with remote trust code, or trust remote code. So yeah, we're trying to work around those things bit by bit through our test suite. They have their fair share of bugs. So, we're just being cautious about rolling it out across the board, because it is kind of a large change. At the moment, in many of our day zero model supports, you can see we instruct you to install vLLM and then install transformers separately, because it'll work for that model, but it might break other models. So trying to keep our heads down on it.
Makes sense. Thanks.
Yeah, any other questions from folks? The next release should be much quicker and easier. We are planning to cut 0.17.0 next Monday, and hopefully release on Wednesday according to usual schedule. I think there we'll probably maintain the PyTorch release the same way as we work on workarounds for the current PyTorch release, or just wait for the next release to come out pretty soon, which we've already started doing pre-release testing on.
All right, I think we can probably give everybody back 20 minutes. This is unusual for us. We usually run over. If you guys have any follow-up questions, vLLM Slack is the place to find Michael and I, and probably everybody else here. Yeah, there's actually some follow-ups here. Go ahead, Michael.
Yeah. As always, keep being active in the vLLM community. Let us know your feedback. Join the vLLM developer Slack. That's slack.vlm.ai. If you want to work on vLLM or other open source projects, we're hiring at Red Hat. Would love to hear from you. And like Sasha said, that's all. We'll keep it light this week. Next time I see you, we'll be in Vienna at a vLLM meetup. So take care, everyone.